Thank you very much, Kyle. By Transformers, I mean like the 80s cartoon and not like electrical engineering. I'm serious. Like, come talk to me about Transformers. Like, they're robots. Have you all been having a great conference? Like, has this thing been amazing? Like, wow, this thing really came together, didn't it? Good job, guys. All right, welcome. My name is Frank. If you want to follow me, that's my Twitter handle. Let's get to it. So I imagine all of us here have at least one thing in common. When Craig Federighi announced SwiftUI at WWDC 2019, we all went, right? Like, seriously, who expected this year? Like, there were rumors and stuff that Apple was creating a declarative UI framework, but I feel like this really came out of left field. And because no one expected this, no one could really prepare, right? We couldn't get ourselves into a spot where adopting this would be easy. And that's left a lot of us thinking, like, now what? The sentiment that I feel on Twitter is that this is very exciting, but like, where does that leave our apps that are currently built with UIKit? What can we do to leverage SwiftUI, and what can we do to get ourselves in the right position to work with the framework? So if this is you, like if you can't drop iOS 12 support in September, or if you won't have, like 6 months to rewrite everything you're doing in SwiftUI, but you want to learn and you want to, use SwiftUI in a real context, well, you're in the right spot. I'm happy to present to you the extremely slow migration guide to SwiftUI. So today we're going to be talking about, we're going to look at the UIKit paradigm, look at like the SwiftUI paradigm, and see how we can like bridge the gap from one to the other. So our roadmap today will be comparing data flows between both of these frameworks. We'll look at an example of moving like a small component from UIKit over to something that plays better with SwiftUI. And then we'll see how we can kind of like generalize this to encompass, larger parts of our application. But first, big disclaimer. I'm making like one huge assumption here for all of this to make sense. And it's that, SwiftUI is really everything that Apple promises, and that, we'll be able to ship this in September. So let's hope, though I'm an optimist, and I think they'll nail it. I feel you don't share my sentiment, but that's okay. Let's talk about data flow. All right. So UIKit and SwiftUI are completely different, right? They're two different beasts. They're from two different worlds. UIKit uses a procedural approach to UI, and SwiftUI uses a declarative approach to UI. Like, we hear this a lot, right? Oh, it's a declarative framework, but what does that really mean? So let's dig in. In UIKit, UI is generated like by a series of events. So view controllers and views cascade to create more view controllers and more views. And then user input happens, at which point we generally, directly modify our view hierarchy, show something new to the user. But then you need to work hard to, manually keep data in sync. And sometimes it doesn't quite happen the way you want it to. And this is normal, right? Like, we're pretty good at getting the happy path right in our applications. But what I've come to learn over the years is that for every happy path, well, you have all of these guys. This is all of the bad stuff that can happen. Like, what happens when you, start this animation while the user is rotating your app? You tell them they're holding it wrong. No, but really, all of this is a lot of work, right? And I remember when I started, I used to think like, oh, all of this like UI kit stuff, like just building UI in general, like is the easy part. But over the years, I found that this is actually where like most of my bugs lie. It's not like in like the backend data layer networking stuff. It's actually all in here. So that brings us to SwiftUI. Like, how is SwiftUI different? Now, imagine you have your SwiftUI view file floating up there. What happens is your view declares its structure up front, right? So it stands on a hill and goes, do declare, this is what I want my view hierarchy to look like. And that's cool, that's interesting. But what's more interesting is that it also declares the data to which it's bound. And this allows SwiftUI to know when something changes and when that view needs to be recomputed. Hence, declarative nature. So now what happens when you want to update your view? Well, some event occurs, boom. You update the state. SwiftUI sees that something is happening, like, ooh. And then, ta-da, look at that magic. Through beautiful keynote animations, our view hierarchy has changed. So if we want to move our app from UIKit to SwiftUI, what we need to do is have like our architecture act more like SwiftUI. And what characterizes SwiftUI? Well, in my opinion, and what's worked for me, is rigid data flow and explicit data bindings. Rigid data flow meaning like children don't update themselves. They update some state that's held by some parent, and then that comes back down to update them. And explicit data bindings in the fact that we know upfront what data can change our view. So all of this is very hand-wavy, so let's look at an example. Boy, I love keynote animations. So this is Meet Podster, the Stumpy podcast player. I like my little Stumpy iPhone. It reminds me of the iPod Nanos, like the fat ones from 2007. Those were cute. So it has a root view, obviously, then an image, a title. It has a little like playback controller and a slider for tracking the time in like where you're at in the podcast. And we're going to focus on one small part in particular. We're going to focus on this playback view here with these 3 buttons because it actually needs to change its state between play and pause. Hey, how convenient. If you were implementing this in UIKit, you might have code that looks like this. Now, this isn't the whole thing, but for this button in particular, you have an isPlaying bool. You have a UI button outlet called play pause button, and then you have an action handle play pause that toggles the isPlaying boolean, that sets the new image on the button, and then that tells the delegate like, hey, this is my new state. A grab bag of best practices right here. So what do we do in order to move this to something that plays a little more nicely with SwiftUI? I would say, first, we need to identify the data that the view relies on, right? Like what can cause this view to change its hierarchy? And the answer to that is the isPlaying bool, right? That everything kind of hinges on that. So we can take that and wrap it inside of a model object. In this case, I guess it's kind of trivial, like we don't necessarily need to do it, but for any view where you're going to have more than one property, you might want to wrap those in a model that represents the state of the view. One might even call it a view model. And then we want to define a single point of entry for all updates to our view controller. So that would look something like this. We have update with playback state. So when our view controller receives a state, it's able to figure out which image it needs to display and then set that image on the button. And then the last part is to let the parent do the update, right? So now, instead of us telling the parent, like, hey, I've changed, instead what we're going to do is the parent is going to get like the real state, like the real source of truth from whatever media controller is controlling the playback of the podcast. And then it can then create a new state that it then sends down to its child. So essentially, we went from something like this, where playback would update itself, and then it would update the play button, and then it would tell its parent. So it was kind of, I don't know what this is. And we moved to something like this, where you tap the button, the parent is notified, it's able to update the state, and then it can pass that state back down to the view controller, and poof, look at that. And notice that these arrows are all clockwise. And by clockwise, I mean unidirectional, they go one way. There's no all kinds of like back and forth. So we've figured out these two criteria. We have rigid data flow, and we explicitly know the data to which our view controller is bound. And so many of you are probably thinking, when do we get to SwiftUI? And the answer is right now. So let's create a SwiftUI view. This, again, the playback button. And what's interesting here is that second line, at object binding state, playback state. What object binding does here is that it tells the SwiftUI framework that this is the variable that we're interested in and that you should subscribe to. But it also tells it that that's going to be handled from outside of the view. And notice also we have playback state there, like, oh, what an interesting coincidence. So our model is back. But now, instead of looking like this, it conforms to observable object. Observable object is the protocol that you want to conform to when you have data outside of SwiftUI that you want SwiftUI to track. It also uses the @published property wrapper to tell SwiftUI, like, this is the property that you need to be watching. So now we can go ahead and use this, and our view, like with only like a minimal amount of changes, our view can now like update its state. So SwiftUI, woo. And then when the time is right, we can go ahead and switch up our view controller with a SwiftUI view. What we do here, we can create the playback state, create the view from our SwiftUI view that we had earlier, and then stick that in a UI hosting controller, which is the kind of the bridge from a UIKit-based application into SwiftUI. So that was a simple example, but how can we kind of expand this to, like more of our app? Like, okay, like, good job, Frank. You're handling one bool. Like, well done. Is that why you came to Toronto? So let's keep going. We can keep moving up our view hierarchy like this, right? So we could create, for example, the podcast view state that handles a podcast. It also publishes the current time, like the current tracking time, and it has that playback state that we had before. And then we can go through the same motions, right? And if you keep, in order to keep applying this to your app, you just keep moving up the hierarchy. And you just keep going higher and higher. And you start from the bottom, and you eventually become world champions. And everything will be ready for SwiftUI. Another common scenario that we run into is if you have a UI navigation controller that pushes like multiple things, like multiple UI view controllers onto the stack. If those UI view controllers are all implement like this one-way data flow for SwiftUI, you can just go ahead and wrap your whole thing in SwiftUI and make it all compatible at once. This is actually really easy to do if you're already using like coordinator patterns. this is not so bad. So yeah. And some of you will probably wait until iOS 13 or 14 is your minimum version before starting to ship SwiftUI. And that's fine. And others might do something like this and like judiciously use @available annotations, you cowboys and cowgirls. If you do this, let me know. I would like to test your app on both iOS 12 and iOS 13. But there is like a kind of middle ground that you can use here where if you create maybe like a user-defined build setting, you can pipe that through to your info plist and then be able to switch on that and decide, and be able to decide like, oh, hey, maybe like in this case, I want to use SwiftUI. And so say like for your own development and for your own learning, but then only ship UIKit out to the world. But really, I think what's important is being able to build this sort of playground in which you can test and learn SwiftUI on like a real world application and kind of get like this like real world feedback on like how you can use it. So that's super interesting. So let's recap. So start with view controllers at the very bottom of your view hierarchy. And then figure out the state they need to display, capture it in a view model. Create a single point of entry for those updates to that view controller. Handle updates through there. Make the parent responsible for those updates, not the view itself. Once you have all that in place, you can go ahead, remove the view controller, and replace it with your SwiftUI view in a hosting controller. And then you just rinse and repeat and, move up your hierarchy. And before you know it, over like maybe a year or two, your app will be completely converted to SwiftUI. Because when we started here, keep in mind that I made no promises as to how long this would take. Because this is the extremely slow migration guide to SwiftUI. Thank you a lot for your attention today.
Awesome. Thank you so much, Frank. Oh, you go ahead.
One more thing. I'm going to be doing a series of workshops on SwiftUI, helping teams introduce this and other concepts. If that's something that's interesting to you, you can go to this link here, bit.ly/swift-to-ws. And on-site, remote, let's work together. Thank you very much.